Hi, all. I'm Vivian Neilley. I'm a product manager at Google. Let me pull up my slides. Can everyone see them? Cool. So I'll be talking about some of the streaming FHIR at scale issues. I've done kind of a lot of work at testing and advocacy for better reporting on FHIR, specifically managed FHIR servers, but kind of any of the FHIR servers, reporting on their performance. I think this is kind of a gap in the market that we have where a lot of folks are trying to either do a use case that requires very low latency or very high, huge amounts of data or things like that, and having a better understanding of which servers are optimized for low latency, high throughput versus which servers can scale to, petabytes of data is really helpful. And so I think that's kind of, that's what I've done a lot of my previous looking into. I'll talk a little bit today about kind of the streaming FHIR at scale requirements, and a little bit of this is kind of a shout out to FAST. So for those who work or attend any of the FAST meetings, they're basically trying to solve some of the problems that we're going to talk about today. I love kind of this slide because it talks about why this is such a critical issue. Specifically number 4, in terms of we are expecting a huge uptick in the amount of FHIR we see in the wild. And right now, there isn't a ton, just from my own experience, we don't have a ton of people coming to us and saying, here's a bunch of FHIR data that we need to bring in, or here's streaming FHIR data. Until the EHRs really implement their FHIR endpoints more holistically and specifically start doing real-time FHIR endpoints, this is when we're going to hit a huge need for streaming FHIR at scale. And so right now, really most of the streaming FHIR at scale we see is coming from EHRs, and I'll talk a little bit about what that means. Just for background, I said I work at Google. My expertise is in Google's healthcare API. So just for overview of where I'm kind of coming from, the healthcare API that we own is a managed service. So essentially, we provide the endpoint and we take care of both the server, the indexing, and the database. I kind of joke I threw in the CAP theorem because Nikolai mentioned that as a trade-off, but we actually run it on Spanner, which there is a white paper out there about how Spanner broke the CAP theorem. So I kind of appreciated that comment because, some of the trade-offs you don't actually have to make. And this is one of the reasons we're able to have such a scalable, globally consistent database and get to the point we need for some of the numbers I'm going to talk about. So just to put that in perspective of what a managed FHIR server looks like versus some of the open source software, when you look at a cloud managed service or a managed FHIR offering, we are in that highlighted bar. So really what this means is we're taking care of almost all of the infrastructure and underlying configurations of the server, of the database, of the indexing, of all the things that I had mentioned previously. There's some trade-offs with doing this. So in an open source world, if you want to go faster, you can just throw more infrastructure at the problem. And that's not always entirely true. There's some kind of caveats with the database and things like that. But in general, more VMs means more throughput. But that also means more money. And so one of the things that's a good, kind of a trade-off, as we were talking about with managed offerings, is you can go as fast as they will let you for the same amount of price. However, you are beheld to as fast as they will let you. And so this is why I talk a lot about some of the performance implications that we have, where if we're going to have managed FHIR offerings and not be as transparent as possible about the limitations of the speed, the performance, the scale, the throughput, et cetera, it's going to be really hard for people to kind of put use cases and start building applications and solutions on top of the FHIR offerings because they have no idea when they're going to hit the limitations of a managed offering. And so there's kind of some trade-offs of you might be able to do it cheaper, faster on a management, but there is a little bit of behind the curtain where a lot of the managed offerings do not have limitations and performance metrics published. So that kind of leads me to the bulk of my talk, which is really where is streaming data to FHIR coming today? As I mentioned, FHIR is not really in the wild as much as streaming FHIR specifically is not really in the wild yet. We see most of our customers coming to us with HL7 and saying we want to convert our HL7 to FHIR, which is probably the most common thing that specifically providers are trying to do today. The numbers of what this actually looks like, and this is the huge caveat here, is this is super back of the napkin math. So I have 5 million HL7 messages per day. That can be wildly up or wildly down depending on number of trigger types they have, number of hospital systems they have, number of bed types they have. You can turn on and off noisy streams. So for example, nursing HL7 is an extremely noisy HL7 feed. And so it really depends, but I kind of like the 5 million as a pretty large implementation, but not the largest I've ever seen. And we take what we would see 5 million messages per day turning into is about one of those messages becomes 20 FHIR resources. And so we would expect around 100 messages a second at peak. And so 100 messages becomes, I have 200 bundles, that's actually an error. 100 messages becomes 100 bundles when you convert it from HL7 to FHIR, as one HL7 message is essentially one bundle of 20 resources. What this really looks like is you need a server who can scale to meet 20 FHIR resources per second. Because even if it's a bundle, the server still has to operate on each of the individual resource. It's kind of a multi-operation. And so essentially, if you are trying to map your data from HL7 at the EMR to FHIR, we kind of say ask for around 2,000 FHIR resources per second. And there's some caveats there that I'll talk about in a second. But just to kind of high level put it together, if you're streaming that amount of data in, that ends up being around 75 terabytes a year. And so earlier when I was talking about the trade-offs of having high throughput and being able to really scale to meet the streaming needs, if you start doing that year over year, it can burden the server where you're at 150 terabytes by the second year and still perhaps streaming in the 2,000 resources a second. And so this is kind of why the scale problem gets accelerated significantly as we go forward, because a lot of people are kind of at the early implementations of FHIR where there isn't just huge FHIR data lakes lying around. But I suspect we will end up getting there in a couple of years. And so thinking about how we can solve some of those trade-offs for huge sizes with high throughput is kind of a really interesting problem and a really interesting engineering conundrum that we have. And so the long kind of, this is a view of all of the CRUD operations that you would need for streaming HL7 to FHIR. You could do mostly creates for this or kind of execute bundles on this one. The issue that I talk about a lot is this is a very narrow-sighted look at the problem. And what I mean by that is, okay, great, 2,000 FHIR resources a second. That actually might not be that bad. But the truth is you need far more than 2,000 FHIR resources per second, because what happens when you are creating or transforming HL7 to FHIR is you end up with transactions. And so what that actually looks like is you could get an ADT, so an HL7 message that has John Smith, and then you'll get another HL7 message that has John Smith. And when running the HL7 to FHIR pipeline, you actually end up with 2 John Smiths because all you're doing is a simple conversion. And what actually needs to happen to be able to make it make sense is you need to reconcile those pieces of information. And so not only do you have to convert all the HL7 feeds to FHIR, you then have to do some upsert logic to be able to build out a single patient record instead of just having lots of patient records or 2 different encounter records that really should just be a start and an end time. And so beyond just the 2,000 creates that have to happen, you now have to do search operations and update operations in kind of a complex logic, which means you may or may not be perhaps doubling the load on the server just to make sure that you are streaming in accurate information into kind of the correct FHIR format, not just those transactions of FHIRs in various different resources. And so you end up actually using the whole kind of gamut of CRUD operations when thinking about streaming HL7 data to FHIR. And this is where the scale implications come really come really front and center, because a lot of servers can scale for the easy CRUD operations, but the second you start adding things like search into the mix and adding the subscriptions into the mix, because you have to notify when to run a reconciliation pipeline, that is when the burden on the server becomes a lot more difficult, because search inherently is going to take more compute than a create operation. And so all of this put together actually equals a lot more load than just the simple back of the map and NAF I was talking about. And I think one of the other things that I like to bring out is the fact that just HL7 to FHIR streaming is, yes, the most common that we see, but a lot of organizations want to stream other data into the pipeline. So for example, we're seeing a lot more interest in device data and DICOM data. You might end up having multiple different sources feeding a single FHIR system. So you're now kind of adding additional ingest sources to a single FHIR server, and furthering the chaos that ensues. The second thing I talk about when I talk a lot about the scale of the system is oftentimes the server is run on a transactional database. So for example, our healthcare API, as I mentioned, runs on Spanner, transactional database. Once an organization has a FHIR database, they often want to do analytics on top of it, which means you are kind of causing contention between the applications that need as much compute as possible because they are production applications, and how do you allow for that compute to not compete with the compute that you need for analytics and training of models and all the fun that kind of the data science team wants to do on top of FHIR. And so we actually split out our FHIR server also streams to a SQL on FHIR in a separate OLAP database, so that we don't have that contention. But I will say we do see that when it is kind of an open source FHIR server where your data scientists might actually be kind of stealing some of the compute from the applications, the transactions that you need to be streaming data in, for example. And so then the final other thing I'll talk about is, this is all assuming that there is a single monolithic FHIR server. Right now in the market, that is actually kind of a best practice because of the referential integrity that we have, where how do you break up multiple different resources, for example. So I think there was a message in about DICOM and how DICOM can kind of stand on its own for a resource, and we don't have that capability. Right now, since it is a monolithic, we are facing a lot of these scale issues. This is why NoSQL grew so significantly, is they've kind of figured out how to better federate a lot of this. And so I have a hint as to what's coming, and we'll talk at the roundtable about it. But one of my biggest considerations is the fact that a monolithic environment, it inherently is never going to be the best way to scale. Is there questions? I can't see the.
Yeah, there is. quite a bit of interest around merge, which you mentioned, like merging of different patient records when they come together. Yeah, can you maybe give more details how you handle this? Is it like fully automated? And
Yeah, we have a product offering to do the upsert merge logic. It's interesting because the best way to describe it is an HL7 feed is like as if you tried to look at your bank statement by looking at each transaction. So I took out $2 and then got paid and then took out 30 cents. And you tried to figure out exactly your, how much money you had based on all of those transactions. What you really want to do is get the summary. And that's what our merge logic does, where it will take all the HL7 transactions, they're admitted at this time and discharged at this time, and merge those together to create the period start end timestamp array. That's a lot of logic though, because you can think about it's not just patients that need to be merged. It's actually also encounters. There's allergies that need to be merged. Sometimes source systems will send snapshots of allergies, or they'll just send updated allergies. And so you have to think about not only each resource, but each field, and how exactly it should be appended, if it should be overwritten. There's kind of lots of nuances for the wide breadth that FHIR data covers. We do have a product offering for it, but it's actually something in the market, like just transparently, we don't see solved that often. I think the fact we have a product for it is pretty unique to us. I haven't seen a ton of FHIR merge or upsert logic out of the box.
Thank you. There is a question from Josh. Thanks, Vivian. I'd love to learn more about subscriptions. For instance, what use cases are driving adoption, and what style of subscriptions are you focused on? R4, R5, backport, or something else?
Yeah, so subscriptions are like my favorite topic, and I think Josh is on, so he can talk about topic-based subscriptions, which is probably, when we talk about scale, topic-based subscriptions are going to be the best way to scale, because you can subscribe to what the use case that you're interested in. So perhaps you're a scheduling app and you're only interested in when admits happen, but you don't need to know about the observations. So topic-based subscriptions for R5 and R4B is really interesting, and I think probably will help a lot of these scale issues. Right now in R4, and what US Core uses is like a subscription for everything. So whenever any update happens to a FHIR resource, you send off a notification. That's what we currently support, and it's very noisy. And it means that you kind of have to tease through the subscriptions and understand why there was a notification, and if that notification is pertinent towards the end use case or your application or your AI model, what have you. So subscriptions are awesome. They're basically notifications. And there's kind of some improvements we're making for FHIR subscriptions in the future.